Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on time-based key value store. Okay, it's a big problem to explain directly. Let's jump into the problem statement, understand it, and start solving. So last time we have solved the lowest common ancestor of a binary tree. You can find it in the list. Please take a look. Let's start with time-based key value store. Okay, design a time-based key value data structure that can store multiple values from the same key at different timestamps. Okay, multiple values for the same key. So like a key value pair at different timestamps and retrieve the key's value at certain timestamp. Okay, I think we need to understand it from the example. Let's go through this part first. Time map initializes the object of the data structure. Okay, set stores the key with the value at a given timestamp. Okay, so they're not only associating the value with the key but also with the timestamp. String get timestamp key and timestamp returns a value such that set was called previously with timestamp previous less than equal to timestamp. If there are multiple such values, it returns the value associated with the largest timestamp previous. If there is no value, it returns empty. Okay. Let's take an example on this one. Timestamp, new timestamp set foo bar 1 stores the key foo. So this will be the key. Value would be bar and timestamp would be 1. Then get foo1 returns bar. Okay, then get foo3 returns bar. Since there is no value corresponding to foo at timestamp 3 and at timestamp 2, then only value is at timestamp 1. Okay, so we have to find out the last greater value, right? So since there is no associated value of foo for foo at third timestamp, we return the one available at first timestamp. Similarly, we are setting again for same key foo a new value bar 2 at timestamp 4. If we fetch now for timestamp 4 for the same key, the new value is bar 2. We return bar 2. Similarly, for timestamp 5 also we return bar 2. Okay, I think I got the problem. What they are trying to do is they are trying to develop a key value pair. Okay, so I have a key and I have a value associated with it. Now they are saying that let's say at 12 p.m. this value is Rohit, or let's call it rank. Let's call it class member. Let's call it class monitor, right? Class monitor is the key and value is Rohit at timestamp 10th, right? Or let's call it a timestamp on 1st of any month. Now what happened later on, that whenever someone would ask who's the class monitor, we can say Rohit, right? Unless this class monitor gets updated. But later on the class monitor got updated and the new class monitor is now Mohit, and this was changed on 6th day. Okay, so if they ever ask that who is the class monitor on day 1, day 2, day 3, day 4, day 5, will return Rohit. But who is the class monitor on day 6, 7, 8, 9, 10, 11 or anything will return Mohit. Similarly, class monitor was changed again and now it's Mahesh on 15th, right? So this was first, this is 6th and change again on 15th. So we are using a normal hash map like the key value pair where key is class monitor, value is Rohit. Key is again class monitor, value is Mohit. Key is again monitor, class monitor, value is Mahesh. But with respect to the timestamps, the values will separate values will be returned. If the timestamp is 1st, 2nd, 3rd, 4th, 5th, 5th, will return Rohit. 6th, 7th, 8th, 9th till 14th will return Mohit. after 15th and later we'll return Mahesh. Okay. So one thing is clear, that we need a hash map, right? We need a hash map, and also we need to store the values key and value and associated timestamp. So with each key we'll store value and timestamp together, right? So for this reason we'll create a timestamp pair separately. Okay. Let's start with the time map first. Since this is our constructor, I'll comment for this one. Constructor initializes the map. Okay, so we can say map is equal to new hash map. Okay, now since we want to put value and timestamp corresponding to one key, we'll create a pair for them. Okay. Actually we have nowhere created this map, right? Let's create this map. Oops, that was my mistake. Hash map of we need a map of string, that will be our key, and array list, so that we can, where we'll store a pair of value and timestamp, right? So this will be our key, this will be kept as a pair in the array list, and with each array list we'll store value and timestamp. So for class monitor we'll have all these three values: Rohit first, Mohit 6th, and Mahesh 15th. And according to the timestamp we'll return the closest timestamp, which is the last bigger timestamp. Like let's say the received timestamp is 5th, then we should return Rohit, right? So we'll put all of value and timestamp as a pair, and put all these values as a list and store with one value. So let's so for pair we'll do one thing, we'll create a class only. Okay, let's create an inner class. Okay, so inner class representing a pair of value and timestamp. Okay, so we'll say class pair. Okay, what all do we need? We need the value, string value, int timestamp, right? Public pair will make a constructor quickly. String value, int timestamp. Okay, this dot value is equal to value, and this dot timestamp is equal to timestamp. We are clear up till here, right? Now we have our pair, we have our time map. Let's start adding. We have to set and get. Okay, so we'll say method to add a new timestamp value pair for a key. Okay, so we are given a key, value, and timestamp. So as we enter values in a hash map, we'll do it in the similar manner. First we check if the value is already present in the map or not, right? So if map dot contains key, we'll pass the key. So if it already contains this key, we'll need to update it, right? So if key is present or already present, add a new pair to the existing list. So we'll say map dot get key, and then dot add new pair, and we'll pass the values, value and timestamp, right? Done. Else if this value is not contained already, that means we need to create a new list and then pass it. So we'll say if key is not present, create a new pair and add it to a new list. So we'll say pair p is equal to new pair, will pass value and timestamp. Then we'll say map dot put, we need to put the key and a new array list, blank for now, of type pair. Right now we'll with respect to the same array list, we'll add the value of this pair. So we'll say map dot get key dot add p. Right, that's it. So this part we could set it. Now the trickier part is the get part, because we do not only have to fetch the value, we have to fetch the value with respect to the timestamp. Now there are different ways to do it, but a faster way would be to do it using binary search, so that we search the timestamp based on the binary search. Let's say the provided timestamp is 7 or 10 in this case, right? I can do a binary search on these available values 1, 6 and 15 and clearly find out the last bigger number, that was 6th. So if I want to do that, that would mean that I must store, or we must store these values on the of pair in a sorted format, sorted on the basis of timestamp, right? Either we can sort them right now, or when we are saving the values in the pair, we can sort them there itself. So let's sort it while saving the values as a pair, right? So for this we can directly implement the comparable class. Comparable interface implements comparable type pair. Okay, what do we have to check? It only has one compare to method, right? So we'll say compare method for sorting pair objects based on timestamps, right? I hope it is clear that why are we even sorting this, because sorting is not required, but we would have to search through all the values when we are doing a get operation and then find the closest value, right? Closest bigger value. So rather than doing this searching in a normal linear fashion, we can do a binary search. The binary search would require sorted list, so we are providing this pair in sorted formats based on the timestamp. So for this we are doing this part. So public int compare to method, which we are overriding, will say pair o, and return this dot timestamp minus o dot timestamp. That's it, right? Now let's start with the get part. The only point here is we have to perform the binary search. Also we have to remember that we may not always find the solution, so we have to find out the last big number. Okay, so let's start. If I'll say if map dot get key is equal to null, right? The base case, we can simply say return empty list. Oops, I forgot to comment. I'll say base case. Okay, if it is not available in the map, we'll return empty, right? Or I'll comment it. If key is not available, return an empty string, since we have to return the solution in string format. Okay, otherwise let's solve it like this. Okay, list of pair, call it list, is equal to map dot get key. Right now int left is equal to 0 for normal binary search, int right is equal to list dot size, since we have to search across the list, and int we'll take one variable for the largest previous value. Initialize it with -1 right now. Okay, why largest previous value? When we are searching for, let's say, date 10th, okay, and I found the mid as 6th, the largest previous value will be updated to 6th. Now for 10th, I know there's no value exists, so I'll search in the lower division or the upper division, but I'll not find any value apart from 6th and 15th, and the loop will finally eventually run out. So the last greatest value below 10th would be 6th, and we can return the value of the class monitor on 6th day. That would be Mohit, right? So we need to store the largest previous value found. Okay, so for this we have created a variable and initialized it with -1. Let's start with binary search. So binary search to find the largest timestamp less than or equal to the given timestamp, right? Because less than or equal to, if we are given 10th day, we have to find either 10th day or some day before 10th day, that would be 6th, right? Okay, so we'll say while left is less than equal to right, normal binary operations, int mid is equal to left plus right minus left whole divided by 2. Then pair, current pair, we have to find out the current pair, that will be list dot get mid. From the list we'll find out the current pair, and then as we find out for the mid, we'll check if it aligns with the current timestamp, then we'll simply return, other we'll check left half or right half, right? So if current dot timestamp is equal to the required timestamp, we can simply say return current dot value. Otherwise, else if current dot timestamp is less than the required timestamp, that would mean we need to move our left, so left would be equal to mid plus 1, and with this we'll update our largest previous value. Now since we found 6th as the mid, right, I suggested, so we can mark 6th as the largest previous value found until we find 10th, and since 10th wouldn't be available, 6th would still be available in our largest previous value. So we'll update our largest previous value, math.max of largest previous value or mid, else it is in the it is in the left side and we have to update the right, so right is equal to mid minus 1. That's it, that is the whole solution. Once we come out of the mid while loop, we'll return the value associated associated with the largest timestamp, right? Largest timestamp less than or equal to the given timestamp. Okay, so we'll say return largest previous if it is equal to -1, right? If it is equal to -1, that means it was not updated. If it was not updated, that means the solution does not exist. So return blank, empty string. Otherwise we'll return list dot get largest previous dot value, right? That's it. That is the whole solution. Let's test. Let's see if everything is working fine. Oh, I hit typos. What's the error? Line number 41. If map dot get key, we have to close this get key. Okay, let's run it again. Let's see. No, we still have something. Illegal start of expression. Are we missing something? There is an extra null. Okay. Let's see. Cool. It's working. Let's submit and check. Now there could have been other approaches as well. There could have been faster and slower approaches as well. But we used the one that used binary search. If we would have used the direct approaches, it would have been much slower. But on the other hand, there are faster approaches as well. Right? If you find one, please let me know in the comment section. Now, once again, what we are doing is, it's a simple problem. We have to save the values in a key value pair only, but with each value we now want to store a timestamp. So there is no problem in storing the values, we can simply store them. The only thing is when we have to return the values. So for the get operation, we have to return the value associated with the key for that for that timestamp, or for the last available timestamp, right? So as we discussed, if we are looking for class monitor on 10th, since there is no class monitor change date on 10th, we'll go for 9th, 8th, 7th, 6th. On 6th was the last class monitor date value changed, we return Mohit. If we were asked on 5th, we'll return Rohit. If we were asked on any day after 15th, we'll return Mahesh. Okay, that's it. And now in order to do the binary search, in order to find out the last previous largest number, we did a binary search. And in order to do the binary search, we saved the pair in sorted format, sorted on the basis of timestamp. Okay, I know this was a pretty long video, but it was a little tricky one as well. So please let me know in the comment section what you think, or if you have an approach better than this one. That's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.